Welcome everyone to the December virtual star party. Tonight we'll be exploring the Geminids, Meteors, and Meteorites. As you all are entering the room, we'll wait for a few more people to join us. Just please note that tonight this program is being recorded. So if you miss any of it, you can always come back and watch it again on the Bell Museum's channels. So welcome. Tonight is going to be full of fun. Enjoying the warmness of being inside instead of outside in the snow. Unfortunately, with the snow, that does mean that we are not out with our telescopes tonight, but we do have some fun stuff to talk about with you all. So thank you for joining us on this nice, cozy, very wintry evening. As we kind of get rolling here, I do want to say that as a museum, we aim to advance our collective understanding of both Earth and sky. And I would like to acknowledge the Bell Museum sits on traditional and treaty land of the Dakota people. I would also like to acknowledge the Ojibwe people, the traditional keepers of our lands to the north. Dakota and Ojibwe knowledge systems are crucial ways of knowing this land we now call Minnesota. And we at the Bell honor that knowledge, the values embedded in it, and the people who keep it. Questions are our favorite part of the evening, so please use that Q&A box here in Zoom to send in any questions you're wondering about along the evening tonight. And our team here is going to be working to answer as many of those questions as we can live, but also some of them we will respond to in the Q&A box written. So please keep them coming in. They're our favorite part of the evening. And then this event is going to be captioned. So what you can do is you can use those the CC button on your Zoom screen if you want those captions or if you want to hide them. So you are welcome to use that should you find it useful. Okay, to get us going, I do want to say my name is Sarah. I am the Planetarium Programs Coordinator at the Bell Museum, which is located in St. Paul, Minnesota. And tonight, we will be joined by Tad, who is usually up on our roof deck, but he has some other surprises in store for us tonight since the clouds are a little bit too much for us to handle with our telescopes. But as we get going here, let's take a look at our star map for this
yes,
month.
Sarah, I am here. I am here outside. It is still snowing. I just want to make sure people are aware of that. We are in for a kind of bad snowstorm. In fact, I think it's fair to say that this is the first great snowstorm of 2020.
2021.
2021, in fact, I'm seeing 2021 now. The first great snowstorm, Snowmageddon, I believe is the name for this one. Great name, best name really for this one. But if you are outside, I hope you're going to go inside. There's a snow emergency in the cities. It is coming down several inches every second, I believe. In fact, if you aren't stocked up on food and water and eggs and milk and probably buttermilk as well, and it's in high demand right now, you want to make sure you pick all that up. The roads are a mess, though. It is ice, it is sleet. The people are skidding everywhere. You couldn't even walk out here. It's too dangerous. So I'm going to head inside shortly. If I can make it inside, if I can find my way in back into the door. It is like a blizzard out here, snow apocalypse, really. So back to you, Sarah. And if I make it back in alive, I will check in. And if I don't, tell Beth I love her.
Will do, Tad. Thank you. It is wonderfully snowing outside, so that would be a slight exaggeration, but all fun here in, yes, a very nice wintry weather evening tonight here in Minnesota. But let's take a look at our star map because we want to know what would be visible behind all those clouds tonight, or what can we see tomorrow if it does clear up. And so we will be putting in the chat box here the link to our star maps. You can always download the most recent star map from the Bell Museum's page. Let's go ahead and take a closer look. As always, if we take a look at our map on the outer edges here, that is our horizon. And then at the very center of our map is our zenith that points straight overhead. And there's some fairly bright stars scattered throughout our map this month. So you have some good opportunities to star hop from one constellation to the next and kind of navigate the night sky here. A few things you might notice is the east and the west, they are flipped. from what you might expect them to be, because star maps are not meant to be read face down. If you had a printed version of this, what you'd do is you would rotate around to the cardinal point that you're facing would be towards your torso. So right now I am facing south, and so I'd hold south to my torso, and then I would flip the star map up above my head and read it. So that way it's easier to view from the star map to this actual sky and make that connection one-to-one. Some other things you might notice about our star map this month is we do have the Milky Way kind of stretching from southwest to northeast. Now that we're in winter time, or almost winter, official winter start date isn't until the 21st. But we are facing away from the center of a galactic, of our galaxy here. So we'll see less and less of our galaxy throughout the winter. But even so, you have to be in a very, very dark sky in order to see it at all. So here in the cities, with all of our light pollution, we're not going to see our Milky Way stretching from the southwest up to our northeast, but it is here on our map in case you get out away from the cities. Some favorites every month are always our planets. So looking down in kind of the southwest corner of our map, kind of that lower right corner, we do see the planets Jupiter and Saturn. Venus is not on our map as it's set already by the time this map is good for, but Venus is out just as the sun is setting right now. So Venus, Jupiter, and Saturn will be visible for the next few weeks, but as they come into the new calendar year here, as we usher in 2022 soon, we'll lose sight of these three very bright planets, but we will start to catch glimpses of Mercury in the new year. Some winter favorites here on our star map are the Pleiades. If we look in the east, we see Taurus the bull and its horns, marked by the bright star Aldebaran. And so the Pleiades are marked by this little blue square there. They're also known as the Seven Sisters. If you look at them with your eyes, you can see them even here in the Twin Cities. It looks like a tiny little mini dipper. It's a cluster of just a small number of stars, maybe 6 or 7. But if you were to look at that object with a pair of binoculars or a backyard telescope, you'd see that it's not just 6 or 7 stars, it's hundreds of stars in a brilliant open cluster. And Tad and I talk about open clusters quite a bit, but that's the topic for another star party tonight. We're here to talk about meteors, meteorites, and the Geminids meteor shower. So again, just a reminder, if you have questions throughout the night, please use the Q&A box. We love to have your questions. And a few have already started rolling in, so let's take a look. One of them is, how many different types of stars are there? Now, Tad, feel free to jump in at any point in time. But for that question, I would say, what are you talking about as a type of star? Stars come in all different temperatures, and then we can classify those, and sometimes those are referred to as types. And so we call those, we classify them O, B, A, G, or yeah, G, B, no, it's O, B, A, fine, gal, I'm forgetting about it. So, O, B, A, F, G, K, M. Thank you. It's hard for me to do that without the acronym right in front of me. I forget what some of those letters are. So we have several different types that way based on stars' temperatures. But then if you think about stars and their different stages of life, you might think of a white dwarf or a neutron star or a pulsar or even a black hole. And so you could maybe call any of those different types of stars too, depending on if you're looking for the scientific explanation of what a star type is, or if you're looking at the kind of wider view of star life cycles. Okay. Another question that's already come in is there a way to adapt and stargaze when there's snow outside? Well, when the clouds are out, it's kind of hard for us to see through the clouds. Our human eyes are not meant to see through clouds, and nor are most of the telescopes we use in our backyards or even at the Bell Museum. That's why we don't have them out tonight. Some telescopes are designed to see through clouds, but they're best placed on mountaintops where there really aren't any clouds to begin with. And that's where kind of radio telescopes come in. So some telescopes can see through clouds. The visible ones that we use at the Bell Museum cannot. They work very similar to how our eyes work.
Sorry, do you mind if I jump in?
Go for it.
Yeah, so actually I'll steal the screen share for a second too, because I just want to jump in and say my favorite way to deal with the snow Incidentally, for those wondering, I did make it back inside. It was a long trek. My hiking poles were off to the side. You may not have seen them, but I did make it back in. Thank you. Thank you for all the comments there, wishing me well. I just want to share my favorite way to sort of get ready to view the night sky before you can view the night sky. And that is with Stellarium, one of my absolute favorite programs to view the night sky. This is a view of Stellarium, the program right now, viewing the sky from here in Minneapolis, the Twin Cities, looking at the sky at about, what are we at, 10 o'clock here. So we can go backwards as well. It is 7 o'clock, so what, 1900? It is showing what is in the sky behind all the clouds. And this is a great way to get ready for stargazing, even when it is a clear sky. It's a great way to get ready to know what to go and look for. Showing you things like over to the southwest, the bright planets, Jupiter and Saturn that Sarah was talking about earlier. The moon is there as well. And then also showing what constellations are up to as a great way to orient yourself to the night sky. And then once you find your way around that way, and I'll add in a few constellations here, you can also turn on what are called the deep sky objects. So as you really start to get into stargazing, whether that's with binoculars or a telescope, there are a lot more objects to see up there than we can see with our own eyes. This Stellarium as well shows you what's up there too. Whether that's actually some of my favorite objects like globular clusters. I believe Sarah and I share these as very favorite objects in the sky, showing you where to find them and where to look off of or nearby different constellations for them, or whether you're looking for nebulas or these open star clusters. Stellarium does it, does it all pretty much.
Yeah, and it's one of the tools that I use quite frequently for planning our star parties and planning what to go see before I step outside. So I have an idea of what might be possible. So you're right. Some pre-work definitely helps even when the clouds are not in our way. And
I see there's a couple questions there. I don't know if those links went out in the chat quite yet, but oh, thank you, Katrina. Katrina put in for stellarium.org is the main site. So that's the program I was using. They also have now, I think it's super cool. They got this going maybe a couple of years back now, a web version as well of their program. So you don't need to download anything. You can just run it through your browser, through Chrome or whatever you're using, Firefox, Edge, I guess some people might be using that. And you can do most of the same things, not absolutely everything, but you can do most of the same things. And they also have an app as well. It's got to pay for the app, I believe. Everything else is free. You got to pay for the app. I have paid, full disclosure, I have paid for it. I think it's totally worth it.
Good to know. One question that came in is, where is Scorpio on this map? I hope you can all see my screen again. And you may notice that we can't see Scorpio on the map right now. And that's because Scorpio is a summer constellation. And so here in Minnesota, where we're about 45 degrees north of the equator, Scorpio is actually just above our equator for a very short period of time, above our horizon for a very short period of time. And that usually happens like in August. As kind of a fun story is that Scorpio is actually in the sky opposite the constellation of Orion the Hunter. Now, Orion isn't yet on our star map here on my screen because this star map is set to like just after sunset around 6 o'clock. If we were to go out more around 8 o'clock, Orion would be rising over in our eastern horizon over by Taurus. But the story goes is that Scorpius and Orion were locked in a battle because Orion is a great hunter, and he claimed this story comes from Greek and Roman mythology, that he claimed he was the greatest hunter and he could hunt any animal on Earth. Well, Gaia did not want Orion to hunt all of the animals off the face of the Earth, so she sent Scorpius to go battle Orion. And through this epic battle between the two, Orion ended up stepping on the scorpion, but then Scorpius ended up stinging Orion. And they were both ended up being put into the sky on opposite sides on opposite seasons, so that way the two will never meet and never fight again. And so if you can see Scorpio, you cannot see Orion. If you can see Orion, you will not see Scorpio. And so as we're getting into the winter season, our winter constellations are becoming a little bit more center stage, including Orion. So take a look for next summer for Scorpio. Now, another fun thing that's happening in our sky, that's more of a temporary happening, are the Geminids. And so this is an annual meteor shower that's actually one of kind of the best meteor showers every single year. Now, the Geminid meteor shower is going to peak this year, coming up early next week, and the nights of the 13th into the 14th. Now, it's good for us because if I'm remembering correctly, that the moon is not going to be too much in our way. Sometimes the full moon gives us so much light pollution of its own that it's actually hard to see the meteors coming in. But with the moon in not quite the full phase, we should have a better chance of seeing any meteors streaking across our sky here next week. In order to find the Geminids, they will radiate from the constellation of Gemini. That's why they're named that. So while they might start over in the constellation of Gemini, which is just over here to the east of Orion next week, starting around 8 o'clock at night, you can actually see them streaking anywhere across the sky. And meteors are a great, fun thing to talk about in showers. And I'm wondering, Tad, do you have any fun tips about the Gemini meteor shower, or fun things we should be looking out for next week?
Yeah, well, I think actually you already mentioned it. From what I understand, it is going to be the moon should be mostly out of the way for this, so it's going to be just that much easier to see it. I love meteor showers though, just because they're so they're out of everything that we could see in the night sky. These are some of the easiest things to look for. You don't want binoculars, you don't want a telescope, you just really want clear skies. Geminids, they're frequent enough that they can be seen even from inside the city. If you can get to darker skies, of course, that's always better. But really just go outside and look up. If this was warmer months, I'd say get a lawn chair and your favorite beverage. But right now, maybe get the lawn chair and also like 6 coats and a blanket, or a blanket and 6 or 6 blankets and a coat, whatever you want there. You just want to stay warm, and yeah, just look for an open area, and just look for them. They do appear from really anywhere in the sky. So just look up. Yeah, it's really, I mean, I wish I had something like more complex here. Like you've got to star hop to this and you've got to narrow down to that and make sure you've got the right eyepiece and everything. But no, it's really, really simple. All things considered in astronomy, this is an easy one.
Yeah, and so kind of part of that, a question came in about which direction from the Twin Cities should we look for meteors or for the shower?
So which direction from the Twin Cities? I would, so I think the big thing here is I'd want to look away from the city lights. So if you're right inside the Twin Cities, or in the area, if you're on the east of the Twin Cities, I would look further to the east. If you're on the west, I'd look further to the west. Again, looking away from the city lights. We do have, I think I still got that link in my head. I can put it in the chat as well. We've got a map of some stargazing sites that I absolutely love sharing. That should be it there.
Yes, that's where some of our Bell staff have put together their favorite viewing sites. That is a great link to use.
All right, you got it there 3 times, hopefully. So those would be some dark skies. So if you want those darker skies, that would be probably some great places to start for where to look. And again, away from lights. That's always the big issue with stargazing is any bright lights.
Yeah, because as the night goes on, the Earth is going to continue to rotate, and so on the screen here, I'm showing you a screenshot of you looking towards the east at 8 p.m. But if you decide to go out after midnight or early in the morning, because sometimes people recommend going out really late at night to see more meteors per hour, you'd be looking more overhead towards the south or even more towards the west, depending what time of night you go look out. So your recommendation there, just look away from city lights. That's a good general recommendation, regardless of what time you go out to look out for them. And because they're streaking anywhere across the sky, you don't actually have to look in the direction of Gemini here, or that's not too far from Orion. You can see them really in any which direction. I'm just wondering, Tad, I forget off the top of my head. Do you remember which comets the Geminids originate from?
Ooh, that's a good one. I don't. If you'd ask me, I see the Orionids marked there. If you'd ask me the Orionids, I know that one because I was researching that earlier. The Geminids might be either from Swift-Tuttle or it might be from Paphion. I'm trying to remember now. I want to say 3200 Paphion sounds a little more right in my head, but I'm gonna double check it. Actually, can I steal the screen share for another
Go for it.
So we're showing a screenshot from Stellarium there. It's incredible. Going back to the full program here, there's a whole lot going on there. One little very cool part of it is down on the bottom. It is the meteor showers search. So you can actually just search what meteor showers are coming up. And this is set up for the entire year of 2021. But if we're looking here for maybe we'll be a little smarter and just do the 12th or so so January here, and we've got the name Geminids. Here we go. Oh, I was hoping this would show me I thought this would show me the comet, but it's actually just showing me how many you might expect during an hour and when it peaks. But
well, what is that hourly rate? Because that was a question that came in.
Oh, was it? Oh, good. Yeah. So you'll see this often in literature, ZHR, which is zenith hourly rate. And the zenith is the very top of the sky. So I think Sarah's mentioned this on the star map. If you're looking at our star map there, it's a nice circle. And the zenith is going to be the very center of that circle. So it's the point up, right up from the horizon, looking straight up above you. And that's how many you would count, how many meteors you might expect to count over the course of an entire hour. If you're getting that sort of, in a sense, perfect view of the night sky looking up. 120 is a lot. I mean, that's a couple every minute. So this is a very, very active meteor shower.
Yeah, and some good things to think about is like, where do you need to be to see this meteor shower? Could you be other places on the globe? And so we're showing you the sky using Stellarium here as it is from Minnesota, where we are, where the Bell Museum is. But because they radiate from the Gemini constellation, if you're in the northern hemisphere and you can see the Gemini constellation, you should be able to see at least a few meteorites at the least. I'm not quite sure how far south in the southern hemisphere you can still see the Gemini constellation, because the sky does change based on your latitude and which stars we can see from different locations on the Earth, but all based on that latitude.
Yeah, and your location on the Earth might change some of what direction you're looking at different times in the night. We see here, though, here I jumped us to somewhere in Europe, I think. I don't know, wherever Stellarium put me when I clicked on the button. I would expect to see the Geminids from fairly far south. They're right near the ecliptic, so I would expect to see them from a good distance to the south. We're here in somewhere headed down into South Africa in this view of the sky. And Gemini is still really high in the sky at midnight. So you'd have a good viewing, good chance to view them, I should say, of course, wherever you are in the world.
Okay, so one of our viewers here kind of brought in that the Geminids here, thank you for reminding us, come from Paphion. So which in their research tells us that it's an asteroid and one of the few showers that do not originate from a comet.
Yes,
and
rock comets, yes.
Yeah, and so if you think about a meteor shower, it's kind of like this big swarm of debris left over from a passing object, often a comet, and us here on Earth kind of drive right through that swarm of things out in space, kind of like when you drive through a swarm of bugs out on a road in the summertime, maybe, and the bugs go splat against your windshield. That's essentially what the Earth is doing when we have our meteor showers. Is the Earth is plowing through those kind of swarms of debris out in space, and all that debris is just kind of slamming through our atmosphere, much like bugs on a windshield. And that's how we see these shooting stars or these rocks streaking across our atmosphere on a regular annual basis.
And
Now,
one of the questions out there, how fast are these going? I mean, meteors are moving at can be up towards of like 10 miles a second. So they're hitting the atmosphere there incredibly fast. So really, we're running into them. That bug on the windshield, right? We're really mostly running into them. So they're going miles per second, thousands of miles per hour, tens of thousands of miles per hour as they enter the atmosphere.
Okay, but there's another timely event. So the Geminids are coming up early next week, but we've had a fun thing kind of show up this week in Comet Leonard, and I saw this in the questions as well. So Comet Leonard is the first comet that was discovered this year. And I think Tad has some fun stuff to talk to us about it because he's been working in the planetarium, getting this model into the planetarium, so we should include it in our shows. And that's one of the great things, and one of the things we love to do at the Bell Museum is to include some of these astronomy events and some of these hot topics and very timely events in all of our shows, or as many of our shows as we can. So Comet Leonard is in our sky for a very brief period of time here. And I think Tad's going to show us some more about it.
All right, I should be. So you'll have to tell me, make sure that I am showing a view of the eastern sky, a bunch of stars, hopefully you're seeing there?
Yes.
Okay, excellent. So if anyone follows us on the Facebook, you may have seen a post a couple days ago saying to go out and look for Comet. I've heard Leonard now is the name. I was saying Leonard, heard Leonard now, however you want to call it. I don't think it cares. It is named after the gentleman who discovered it, though, G.J. Leonard. Maybe let's go with Leonard. So we'll want to check with him and see if he cares. But we had a post on the Facebook a few days ago saying to go out and look for it Wednesday morning. I actually went and grabbed a pair of binoculars from the Bell Museum, pair of 8x42s. I was really excited to wake up at 4 o'clock in the morning, excited. And it was cloudy, at least where I was looking, so whatever. But looking at the weather reports, this Sunday morning is supposed to be clear as it gets, at least right now in Minnesota. So it looked only about like 20 or 30% cloud covered. So the sky that we're seeing here, the screen that I'm sharing there, is showing the sky Sunday morning at about 6 o'clock, or looking now at 6:15. Now, at this time of the morning, Leonard is still pretty close to the horizon. So if you have trees and buildings in the way, that's going to be kind of a hamper to you seeing it. If you can get up top of a building, get out into a big wide field, into looking out over a lake, for example. Don't go out on the lakes yet. It's not quite that cold yet. But if you can look out over those open areas, you could look down near the horizon and you could hopefully see this little fuzzy patch of light. And it'll be visible there starting around 6 o'clock, it'll be right at the horizon, and it should be visible for going on about a half an hour to an hour. Sunrise is around 7:30 or so. Of course, it'll get harder and harder to see as the sun starts to rise, as we get the glow from the sun. But that right there, marking it out, that is C2021 A1 Leonard. And it will be a little fuzzy patch in the sky. I'm not going to try to sort of oversell this in a way, but it is also going to be one of the coolest, absolute most amazing things you could ever see in your entire lifespan ever. So you better go out and see it while you can. It's just going to be the greatest thing. Nothing is compared to this. I know some of you maybe gotten married recently and you thought that was a pretty great day. No, that was nothing compared to seeing a comet. Congratulations. And I've been lucky enough to see one comet in my life. Not Neowise. Last year was Neowise. I did not see that one. I saw clouds and bugs eating me. It was a comet about almost a decade ago. They are such a cool sight. That little fuzzy patch that we're seeing is immense. The tail of that comet that we're seeing that causes these meteor showers, that stretches out for tens of thousands, hundreds of thousands, or even millions of miles behind the comet. It's all coming from what's happening right down at the center, really what makes up the comet itself. You might have heard comets referred to before as dirty snowballs, and it's somewhat true. It's almost what we see outside right now. If you've been shoveling already, I did a little myself. When you scrape up that snow, it's not just frozen water, it's mixed with a whole lot of other stuff. That's what makes up a comet. frozen water, but also dirt and rock and other types of gases or ices as well. Things like frozen nitrogen or carbon monoxide or dioxide, all these different elements and molecules. And as these comets get close to the sun, they warm up. The sun's energy hits them, it warms them up, and those tails grow off of them. That debris gets left behind, again, giving us these really, really beautiful meteor showers. Now, I mentioned there that this will be one of the greatest sights of your life ever, so you should go out and see it. And I really can't stress that enough, in part because if you don't see Leonard, in the next few days or next couple weeks, we might see it briefly in the evening sky in about a week or two. If you don't see it, you will never see it again. Leonard is a really incredible comet. When it was first found, its orbit was pretty typical. It was an elliptical orbit. It was a roundish or very stretched out oval type of orbit. Very similar then to what we see here with the planets. So the planets or dwarf planets or other asteroids going around the sun, they're all held by the sun's gravity and they're going around it very nicely, and they'll just do that for billions of years or whatever. But Leonard, not the case. As it's approached the sun, it's been picking up velocity from the sun. It's been gaining speed, and it's gaining enough speed that it's reached escape velocity. Really, as it goes around the sun, as it reaches its closest approach on January 3rd, it will finally become hyperbolic. Its orbit will be open-ended. It will escape the sun's gravity, never to be seen again. So if you don't see it now, you're never going to see it again.
So I have a question about that, Tad. If Leonard is coming around just once, do you have an example of a comet that would repeat and come back occasionally, maybe during a lifetime?
What a great question. Where did you come up with that amazing question? So yeah, there are many comets that are elliptical. So there are many comets that are hyperbolic. There are many comets that are elliptical. One, maybe the most famous comet of all comets, besides the reindeer, of course, would be the comet Halley. Halley's comet is the first comet discovered, confirmed to be sort of what it is by the astronomer Halley, and it is due back around the Earth in 2061. Right now, Halley's comet is very far away from the sun. It is out at a distance that I actually don't remember off the top of my head. Someone else will have to search that one out for us. But it is very far out there, out beyond the orbit of Uranus, almost the orbit of Neptune here, in fact, in the outer Kuiper belt. And it is slowly coming back in here. So if you keep your eye on the sky, going on at about 40 years here, Halley's comet will be coming by on the peak of the dates look to be in mid 2061. So looking around June and July, it'll come into the sun. It'll grow that beautiful tail. It's supposed to be a really great, comets are notoriously hard to predict. So, well, I guess it's 40 years, so I can say whatever I want. Who knows what you all remember. It's going to be the greatest comet of your lifetime in 2061. But it is supposed to be well positioned in its closest approach to the sun. We're going to be looking nicely out towards it. It should be really great. I'm always very hesitant to say anything really specific about comets, actually, believe it or not, despite what you may have heard tonight. It is also the source of another meteor shower. Oh, actually, let me backtrack for a second. And this is a periodic comet. So this comet does come around every 85 years. So there's a good chance that many of you actually, you might know someone who's seen it before back in the, 70s or so. It was the last time it came around. You might know someone who's seen it. You might know someone who saw it then and will actually get a chance to see it again. So being able to see it twice in their lifetime. And so if you went, depending on the age of who's talking, who's listening here, some of you might see it. And I think, the way medical advancements are going, I suspect many of you listening, if you get to see Halley in 61, you'll see it again when it comes back around again in 2140, which is a crazy long amount of time, it seems, but not that long in astronomy.
That kind of gets into the idea of how do we predict when these meteors or these comets will come around. So some like Halley have orbits that we can calculate their period for, just like we know the period or the time it takes the Earth to go around the sun, we can calculate their period or the time it takes these comets to go around the sun. And so that's how we can kind of predict some of these more regular comets. But we didn't know about Leonard before this year. And so that was actually the first comet discovered this year. And it turns out that it's going to come and it's going to go and it's not going to come back. So comets can sometimes be harder to predict if they haven't yet been discovered or if there are hyperbolic orbits like Leonard here. And then some of them will leave behind their kind of a swarm of dust and particles that then can turn into a meteor shower like the Geminids. Because if you look at, as we were flying through there, Tad, I saw beautiful comet tails, and I saw two comet tails. Because as the comet, which Tad wonderfully described as this big slushy kind of dirty snowball, as it is approaching the sun and as the sun is heating it up and melting all that ice that's been frozen for hundreds or if not longer years, it'll actually have two tails coming off it. One will be kind of a dust tail, some of those more physical debris, so the chunks of it or the rock that might be mixed into it. And then we'll also get a gas tail coming off of the comets. So you do kind of get these two tails kind of spreading out of the comet here as we fly through the tail of Halley one more time. So they are wonderful to see because you can kind of tell their direction. Their tails are always going to be pointing away from the sun. And that has to do with because the sun is that source that's heating up and kind of essentially evaporating or blowing off that material from the comet as it does get closer to our home star.
And I'll try to fly out a little bit here to see that one again. Right,
and I did get a chance last summer to see Comet Neowise during before the vaccines became available. My husband and I went out and we used a site on that star map or that map of favorite Bell Museum staff viewing sites. We went out and saw Comet Neowise. So comets, they're fun to go look at, and they are fun because you don't need a telescope, but it is cool if you happen to have one.
Yeah, and we can, I think, hopefully see those pretty two distinct tails there. So these will show up depending on viewing conditions and everything, of course, that goes along with it. These do show up, especially in photographs. The bluer ion tail of ionized particles is a little bit more massive and it's being pushed out a little bit more directly. The lighter dust tail there is sort of swooping around as it's pushed out by the sunlight and then also changed a little bit by the motion of the comet as well. So they are incredibly complex and can be especially complex depending on what comet it is, how many times it's been around the sun, what sort of activity is going on, how close it's getting to the sun, all manner of different things working at play here.
Before we get too far away from Leonard or Leonard and into comets in general, Ted, can you remind us, like, when could we actually see Comet Leonard? Because earlier in the week, I think it was up in the morning, wasn't it? Like, what time of day or night could we go outside and try to see it?
Yeah, so again, I would go out in the early morning. I'll actually try to get back to that view here. It'll take just a second. Get back to that view of the early morning looking to the east. So looking in the direction the sun is going to rise. You're going to want to look before sunrise. And that's going to be over the next couple days. So we jump back to our view of the sky here. And let me see, where did Leonard go here? There it is. And there is, all right, there's east. However, over the next few weeks, as Leonard moves around the sun, it will be slowly moving inwards very briefly into our early morning sky. So if y'all indulge me for a second here, I'll see if I can't get that view set up kind of quickly here. Should I say morning, early evening sky? And to see it is going to be a little more, oh, well, it would help if we were at the right time of night. Now, wouldn't it, 1900 or so? Let's see if we can't track down Leonard there. It is going to be a little more difficult to see from what I've seen. It is not getting very far above the horizon. So what I might do here, actually, one great thing is when it comes to sort of quickly searching the night sky, I'm actually going to jump us back to Stellarium. So I've actually been using our planetarium software here, which requires a little bit more setup. Stellarium is a great sort of load it and go kind of program. And Sarah, if you just give me a second, I will stop my screen share. I'll get right back to you.
Yeah, we've been talking about how our comets are orbiting out in our solar system, really, and when they're really far away, there's these frozen balls of slushy, icy, dirty snow, essentially. So they are frozen. There's some rock in them, but it's a lot of ice, and some of that ice might be water ice, but it might be frozen other materials that would also form in ice. But a question came in about if a comet passes by the sun, will it one day eventually melt away? Some comets, their orbits do actually take them and they will eventually crash into the sun, and absolutely it would then just kind of evaporate and vanish and kind of just vaporize. That's what I was looking for. Some comets, like Tad showed us, like Halley, are in a stable orbit around the sun where they don't get too close where they completely melt away. And I don't actually know how long some of those periodic comets would last if they keep melting over the course of every cycle, of how much material they have and how long we could expect to see them for. That's a great question. I would think it would probably depend on the comet itself. Each comet's going to be very different in its composition or in how big it is. And a question kind of related to that is how old are some of these comets? Now, I'm going to pose that question now as kind of a teaser, because some of this material we're flying through that it's leaving out in space, the Earth flies through, and that's how we got the meteor showers. And so we'll be talking more about meteors themselves in just a little bit. And we can kind of start talking about how do we know, why do we care about them? Why do we care about the space debris that falls down to the Earth? And part of it is they hold stories about what the solar system used to be like. So I'm going to tease that a little bit. We'll go more into these meteors that do actually make it to the Earth in a little bit. So stick with us here. Let's see here. Another question came in. If it gets past Venus's orbit, will it start to be caught by the sun's gravity? As comets fly into the sun in our solar system, in fact, it's probably already going to be caught by the sun's gravity. If it's orbiting something else like Jupiter or the Earth, it probably wouldn't be this periodic comet. It'd be more of like an asteroid. And there's some similarities between comets and asteroids, but there are some differences that really tell us that they belong in their own two separate categories there. So if it gets past Venus, it's probably already caught by the sun's gravity. Absolutely. And then another great observation came in, or a question about what would happen if once the comet gets too far away from the sun, it absolutely would refreeze. And so it's only really when it gets closer to the sun does the sun's heat start blowing some of the material off and start evaporating the material that we see those big long dust tails and ion tails. Once it gets far enough away from the sun, those tails will seem to disappear, and that's why we can't always see Halley when it's on the far edges of its orbit, because it's not giving off those telltale signs, those gorgeous tails here that we see when we're looking up at the night sky. Okay, so as Tad is going to show us a few more cool things about the sky, I'm going to steal the screen back here.
Oh, well, before you do that, very quickly. So Leonard will be up in the morning sky here, starting around, actually, I'll go backwards a little bit, starting around December that's not quite right. We are looking here at 5 p.m., so shortly after sunset, but I would start looking for it probably around the 14th or so in the early evening sky. 5 o'clock is actually maybe a little ambitious. I know the sun is setting earlier, but that's still going to be decently bright. Maybe 5:15, 5:30 if you can really sort of push it there. It's supposed to be slightly better viewing in the early evening because we are looking sort of directly into Comet Leonard, so we're getting some extra scattering of sunlight from the tail. So it's supposed to be slightly nicer as we look forward to that evening sky. It is still decently low to the horizon, all things considered here, now looking about 5:30. Looking to the southwest as well. So again, being higher up in a building, looking out our big open field or lake, those are going to be some other great ways to see it as well. There were a couple questions I'll jump in and answer about the naming. I love the naming of objects in the sky because there's some really complex stuff going on. When it comes to comets, comets get the name, usually named C and then dash, and then the number after that is the year they were found. So C 2021 is the comet found in 2021. A1 was that tells us when the comet was found during the year. Astronomers use something called half months to split up the year. So A refers to the first 2 weeks of January, B is the second 2 weeks of January, C is the first 2 weeks of February, and you get the idea. And then the number is that comet, the number of the comet found in that particular half month. So C 2021 A1, very first comet found in the first 2 weeks of 2021. And then after that, that longer name, for example, Leonard, it's named after the person, or nowadays really the sky survey and the telescope that found it. So Leonard is named after a person who found it, just like Halley's Comet is named after a person. Other comets, though, we mentioned one like Neowise, that was found by the Neowise Sky Survey. So an automated sky survey that happened to find a comet, which is the way most of them are found these days. You might see ones like ISON or Linear. These are other sky surveys that find lots of comets. The ones found these days are mostly found, though, through these sky surveys because they're very small. And when they're very far away from the sun, as Sarah was talking about there's no tail going on. There's not a lot of energy. So they're just these chunks of rock and ice. By small, as someone is asking there as well, I don't know if we know exact size on Leonard, but I'd guesstimate somewhere around half a mile across, maybe a mile if it's really one of the bigger ones. But cosmically speaking, very, very small.
Yes. And so as these comets pass by, we've said they've left behind these clouds of kind of debris that, while they're in space, this debris is called a meteoroid, which would be slightly smaller than an asteroid. So the difference between meteoroids and asteroids are really just a size difference. So when a rock is in space, it is called a meteoroid. And most of our meteorites we find on Earth do actually come from the asteroid belt. That's a common origin of many of the meteors we do find here on Earth. But as soon as that rock from space comes hurtling through our atmosphere, we call it a shooting star, and that is called a meteor for that brief period of time where it is in fact streaking through our skies. But if it hits the ground, if it survives that trek through our atmosphere, and if it does hit the ground, that's when we call it a meteorite. So 3 different names for essentially the same object, just based on where it is. Is it still in space? Is it actively traveling through our atmosphere? Or did it survive that intense journey and actually hit the ground? So that's really the difference between these 3 names for this rock from space that can be on the ground sometimes. But most of them actually do just vaporize. So we don't actually get some nice meteor chunk to actually look at, but most of what happens to streak through our atmosphere does vaporize. That's one of the great things about the Earth, is that we have our atmosphere as a protective shield. It protects us from a lot of debris from space, from causing some damage here on the ground. So the reason why Earth is now around and why life has had time to evolve here on our home planet. So what happens if you think you found a meteorite? So you think you found something that was once streaking through the sky and it landed on the ground. How do you know if you have a meteorite or just a normal rock? There's a handful of kind of some self-tests that you can do to kind of narrow it down, but to truly get verification that you have found a meteorite, you will have to send a sample of it in to get tested. But what can you do at home just to kind of rule out if you have or have not found one? The first thing to know is that a meteorite, because it's hit the ground, is going to be very dense. It's going to feel heavy for its size. So it's going to be a heavy rock, something that you would not expect to take that much effort to pick up. So meteors are very dense. Second, most meteors are magnetic. Not all of them, But if your rock is not magnetic, there's a pretty good chance it is not a meteorite. So definitely take a magnet just from your fridge and see if it'll kind of attract that rock. But there's other steps that you can do. Meteors, once they come in through our atmosphere, they often have these thumbprints. You can kind of see it looks kind of like clay or Play-Doh that you've molded and has all these little divots in here. So having thumbprints on the outside of your meteorite or your rock is going to give it a good sense that it actually has traveled through our atmosphere and experienced those intense temperatures as it was streaking through. There'll also be a fusion crust. And so here we can see the inner part of this meteorite, and then around the edges, as we have this kind of cut sample, there is going to be this crust that forms. And this is kind of where the crust, where those thumbprints happen, is the outer part. And that's where all that heat from entering Earth's atmosphere is going to kind of melt that outer edges of the rock and create this like fusion crust. And that crust will be kind of gas-like or glass-like, if you will, except for if it's been left outside for a long time. Let's say it landed in a field of some sort and it was left out with all the other rocks here on Earth, that fusion crust can eventually weather away. And so you might not have that if that rock has been exposed to the elements here on Earth. And then kind of that fusion crust here is it's gonna be fairly thin, and only about like 1 to 2 centimeters. So you can kind of just see that thin coating along our image here on the left-hand side of the screen. And most meteorites are gonna, or I should say, some meteorites here actually have these kind of spheres in them, these chondrules. And so it looks like it's kind of a bunch of stuff that got stuck together. And so here is a window test, if you will, where somebody is sliced into a meteorite and seeing kind of the inner workings of it, of the composition. And so often meteorites will have kind of this chondrule look to it, like little clump of rocks kind of clumped together. But then you could also kind of go back to your geology class, if you haven't taken geology in a while, is a streak test. So what type of streak does it leave behind if you were to scratch it against an uncoated ceramic tile? Now here, hematite and magnetite are two common meteor-wrongs, where they are often thought to be meteorites, but they leave these colorful streaks. So hematite can leave that rusty color streak, or magnetite leaves more of a gray, kind of more graphite type of streak. So these are some streak tests by some common Earth rocks that often get confused for meteorites. And meteorites come in several different types based on what they're made out of. And we have several of them here at the Bell Museum, so we'll show you some of those. But one common type is a stony meteorite. So it's going to be made out of a lot of stone we have this, again, this fusion crust on it. But then we also have iron meteorites, where if you were to cut it open and see kind of this window test, is what they call it, we see the iron crystals as they solidify, kind of in this case, making a beautiful kind of crisscross pattern. And so this would be an iron meteorite. And of course, you combine the two and you get a stony iron meteorite. This one is particularly gorgeous, I think. You can see kind of that iron nickel mixture kind of weaving its way between kind of the more stony aspects, the inclusions in this. And in this particular one, the inclusions here are a mixture of olivine, I believe it is, in this particular sample. And so you can kind of this combination of stony and iron meteorites. So these are kind of the three main categories of them. And how do we get them? Well, it turns out that in space, there's what's called differentiation. So when you have a body like an asteroid or something that might eventually turn into a planet or a moon, the heavier elements like iron will kind of sink to the core of that object. And then the lighter elements, the kind of stonier elements, will kind of float, will be lighter. They won't be as dense. They'll kind of float on top of those denser iron parts. And so the composition of a future planet or asteroid we call it differentiate. So we'll separate out by kind of what those elements are made out of. So here's an example if we were to cut open kind of this forming planet where the iron would kind of sink towards the middle and then you get a layer of lighter material. And in this case, if there was even lighter material, let's say a future planet has water on it, that would kind of be kind of on the outer layer. It's in that middle transition layer between the iron layers and the stony layers, where you get that mix of iron and stone. So you kind of, what a meteorite is made out of kind of gives us a hint at where was it made, or where in its original parent body did it come from. So I just think some of these pictures of these meteorites are gorgeous, and they are in some cases like time capsules of the early solar system. Tad, do you happen to have, I don't know, I have a pair of earrings made out of meteorites. Do you have a meteorite at all?
I don't. I wish I did. I have seen some beautiful meteorites. Where I went to university, there was a fantastic meteorite museum at the University of New Mexico in Albuquerque. There's a really cool meteorite museum. Dr. Carl Agee might still be running it. Fantastic guy. I've seen some cool ones. I have never gotten a chance to actually, I don't even think I've gotten a chance to touch one when we had the lunar samples here, I guess, the museum, but not quite the same thing. But no, maybe one day, maybe a great Christmas present. Someone I know might be watching that. Maybe we can rethink our Christmas present ideas here.
Yeah, I actually have earrings that are just little bits of a meteor, of a larger meteor. I actually have a necklace too. So I have a few pieces of jewelry with rocks here from space that if you didn't know any better, you might just think it's a regular rock. But the idea that these things have traveled so far and have reached the Earth, and then I get to wear them, I find quite spectacular.
I'll have to try them on next time I'm at the museum.
Yes. So some questions came in. Are stony meteors magnetic? Stony meteorites are probably not as, or they may be magnetic, but most of them maybe not be. And just because you have a rock that is magnetic does not mean it's automatically going to be a meteor. And so that's just the magnet test, if you will, is just one way to help rule out if you have found a meteor or not. Most meteors are going to be magnetic, but there are a group that will not be. So it's not the only test that you'd want to use if you think you found a meteor. But Tad, have you ever heard, or kind of, what are your thoughts on if you wanted to go find a meteor, where would you go meteorite hunting?
Personally, I would go to Antarctica. That would be my first place to go. Yeah, I think I saw that we're in the US where to go. Antarctica, which is an international territory, not US territory. And for really the things you mentioned, I mean, the pictures we've been seeing, I think might help make that clear. Maybe go back one image, I think I was seeing that these stony iron ones, they're very dark. Oh, there's a beautiful, that's the, did you mention the, I can never pronounce the name, but that patterning that we see there is.
I did not, yeah, I'm with you. I can't pronounce that name of that pattern,
It's so
but it's
cool.
gorgeous.
But anyway, yeah, these are very dark objects, whether it's metal or rock, they're very dark. And so they're very hard to find if you've got a lot of rocks around you. In Antarctica, though, you have a bunch of snow, at least for right now. And meteorites show up very nicely on that. So when these meteor showers happen, you can get a large infall or flux of meteors falling on the same area, and they can collect together. As the ice and snow moves around very slowly as the glaciers flow, these areas also get clumped together. They get sort of, well, yeah, clumped is the right word for it. And so you can find large amounts of meteors in one area. But they stand out really nicely, and there's a lot there to see. That is my place to go. They can appear anywhere though. They're in fact right here in Minnesota. No, I guess it's a little different than a meteor, but there's a first suspected impact crater found in Minnesota, actually, or at least in the local area. So they can be found anywhere. Just depends on how much time and effort you want to spend looking for them.
Yes. Teaser. There is a local meteorite hunter, if you will, and I'll show you some of what he's found over the years here coming up in a few slides, that has looked on the rooftops of buildings like the Bell Museum and found stuff. So we'll get to those kind of smaller meteors in a little bit. And let's see. So let's go through this. We talked about different types and how we get them. Here's a sample of the Bell Museum's meteorites you can see at any time if you come to the Bell Museum and visit us. So we have a great view of this very large one in the middle that was found in Forest City, Iowa. And then over kind of on the left-hand side, or the right-hand side, we have kind of that a mixture of that stony iron, because we have a lot of those kind of inclusions or mineral inclusions weaved between the nickel and iron metal parts of the meteorite. And then over on the left side, we have a smaller sample of kind of an iron meteorite. So we have these great examples at the Bell Museum. You can come and enjoy them anytime you visit us. So we see the fusion crust, we can see those thumbprints. So let's take a closer look here at the things that we have. So this was actually a fragment of an asteroid that passed close enough to Earth and left this chunk that was found in the late 1800s, just south of the Minnesota border, down in Forest City, Iowa. And this is a quite sizable meteorite. So I wouldn't necessarily think that you might find one of this in your backyard. If you do find one, or if you do go meteorite hunting, you'll probably find something a bit smaller. So this one's actually a fairly substantial size here. But looking at this kind of stony iron one, again, these inclusions make it gorgeous. And so we have that iron nickel kind of structure with the olivine, which is rich in magnesium and silica kind of woven in between. So this type of meteorite would come from that area as it's transitioning in that protoplanet or proto-asteroid, where the heavy materials are sinking towards the core of that object and the lighter materials are kind of floating towards the top. This will kind of have formed in that transition layer. So it kind of gives us an idea of the snapshot in time of when things were forming in outer space. And then this is a small sample, because sometimes you just don't know if you found a meteorite, and you do need to send it in for a window test, or it's where we slice the meteorite to kind of see what the insides look like. And this one doesn't have the as prominent of those iron crystals cutting across it, but it does give an example of the third type of meteorite here. And this one was just a sample of a larger object that was entering the Earth's atmosphere that just exploded. And so some of you might remember back in 2013, one exploded over Russia and broke up into smaller fragments. And so they can appear anywhere. We don't always know when they're going to come to the ground. A few things though, if you think you found a meteorite, that telltale signs that they are not meteorites. Meteorites almost never contain quartz, which here's an example of a rock that has those quartz, the kind of clearish mineral crystals in it. They very rarely ever contain bubbles or look like river rocks. So here's a few common things that they will not have. Very common misinterpreted meteors are pyrites and iron ore, like this image here. This is iron ore that has a lot of hematite in it to kind of give that rust color, because iron ore is going to be fairly heavy for its size, much like a meteorite you'd expect it to be. But these are often mislabeled as meteorites, and that's why you'd want to try to do that streak test or do several of those tests at home to see if your rock is in fact a meteorite, or if it's something that has a little bit more, has a earthbound origin. A great observation or questions that came in about have we found pieces, or scientists have found pieces of Mars on Earth? And so yes, we have. So meteorites don't always have to originate from asteroids or comets. We actually do have a chunk of Mars that at some point in time broke off of the planet and happened to come hurtling to Earth and landed on Earth. We know that it's from Mars because it has a different chemical signature than the rocks we have here on Earth, or even the rocks that we found on the moon. So we do have a piece of Mars, but that just happened to come to Earth. We would love this to happen if a chunk of Venus were to happen to break off, because then we'd have 3 planetary rocks to look at. But we are going to be going back to Mars and picking up some rock samples there that the current Perseverance mission is caching for us, essentially. So one day we'll have more of those Mars rocks to analyze and figure out how is Earth similar, and yet how is it different from the other bodies here in our solar system. Okay, I told you I was.
Sarah, can I just jump in also to say that that's the Allen Hills meteorite in particular is probably the most notable one found, named after the region it was found, Allen Hills region of Antarctica.
It is definitely way easier to find meteorites when they're dark against a pure white background. But you don't always have to travel to Antarctica or the Atacama Desert in Chile. Sometimes, like some people here in the Twin Cities have done, have found micrometeorites here on rooftops. And so we had a wonderful exhibit a while ago, and we have this blog that we have up that kind of describes these micrometeorites. And so you can kind of see on the left-hand image here, a zoomed in, a very magnified image of this micrometeorite. And then on the right-hand side, you can see just how tiny it really is, just from that image of a micrometeor and a person's finger here. So these are going to be tiny. But they are really fascinating because they kind of come in a classification system. So they're not just stony or iron or a mixture of stony iron, because these are tiny, tiny, tiny. And so they've classified these based on the physical features they've noticed. And from these physical features, they were able to figure out at what temperature was this piece of rock from space hurtling through our atmosphere at to help cause and shape the meteorite that actually does hit the ground here. And so on the far left, we can see here, kind of below the 2400 degrees Fahrenheit mark, we have an unmelted piece of rock here. But once you start getting over that temperature marking of about 2700 degrees Fahrenheit, you start to see some shapes kind of appearing based on its trajectory and its speed and the temperature at which it's entering our atmosphere to kind of give some of these characteristics here. And so Scott Peterson is one of our local Minnesota volunteers, or I guess he just does this because he loves finding these micrometeorites. And he's found these here locally on building tops. And so they are gorgeous. And so he finds them by searching building tops with a very, very strong magnet. Again, going back to the idea that most meteorites are going to be magnetic. And so he collects a bunch of magnetic material from the tops of buildings. He gets permission to go on the roofs of buildings, of course. And then from there, he can sift through the material, he can wash it out, and he goes and works with somebody to help image these meteorites. And so you can kind of see in the middle top here, it kind of has that more elongated, pointy, not quite an egg shape, based on how it came through our atmosphere. But some of them over on the right-hand side, we can kind of see little beads of metal kind of embedded in the rest of that glass. It's kind of been smoothed out as it's entered our atmosphere. So each one is unique and gorgeous, but very, very tiny. Oh, not there yet. So we still have plenty of questions coming in. So let's take a look at what you guys are wondering about. One question is coming in is, does Jupiter's gravity save us from lots of meteorites? Tad, do you want to take this one?
It's an easy question. Yes and no. There we go. So Jupiter's gravity is probably very, very important. As things come in around the sun, Jupiter's gravity probably deflects them. For example, we know that Comet Schumacher-Levy impacted Jupiter. So Jupiter's gravity pulled it in and nudged it over time, and it smashed into Jupiter and broke up in its atmosphere. So Jupiter very clearly does help sweep out a path around it as planets do and collect things, so that will keep things from impacting the Earth then. But it's also very probable that Jupiter's gravitational pull, it tugs on objects, and so it can cause things to get deflected very slowly over time and start moving in towards the sun, and potentially then could impact the Earth. So, it's yes and no, really. Sort of to go along with that, the coral there, I love the name, by the way, asked how many meteors are in the sky. And, just from looking at something like the asteroid belt, if we're looking at the potential sources of rocks impacting the Earth, there are, I believe we're up to several million asteroids that we know about, and probably tens of millions and more left to be found. Most of those being the very small ones that would give us beautiful shooting stars in the sky. Do you want to keep going? Sorry, there's a few more questions I see here.
If you have more things you want to answer, go for it. There's yeah.
Yeah, well, the two top ones I'm seeing, and I'm sorry, I see they were asked a little while ago, and sorry we didn't get to them. I'll take a minute. Joseph asked about upcoming events for January. So I'll actually promote myself right here. Every month I do our Minnesota Night Skies Live on Facebook. And that's when I talk about what's coming up in the sky, what to look for the next month. So it should be under the Bell Museum Facebook events section. You should see those listed for coming up the next few months. The one, if it's not there, the one in December should be on the 28th, as I very quickly look at my calendar here. It should be on the 28th at around noon is when I believe I'm doing it. So keep your eye on the Facebook page. We stream those from Zoom to Facebook. You can ask questions about what's in the sky, and I'll talk about what's up there. And then also Jody asked a little while ago, there's a joke about the movie Contact in there, but I don't know how to make it right now. How does water get into space? This is a fantastic question because it's always been there. The water that we see there it's very simple. It's hydrogen and oxygen stuck together. And we find those two elements across the universe. They're two of the simpler elements that we see in space. So their ability to stick together is quite common. We find evidence of water really everywhere we look these days. We find it in the rocks, bound up in the rock particles and asteroids. We find it in moons in the outer solar system. We find water on Mars, of course, all frozen, except for those moons, actually. We find it, we are hoping to find water. We think we probably will start finding water on other planets going around other stars, as well as just in these clouds of gas in space. So that water is all out there already.
Okay, so a question about the streak test.
I'll jump in and say, Katrina, who's been behind the scenes answering questions, she just let me know as well. And I suspect this might be part of her work. So if she wants to jump in and answer this as well, she can. But she notes that we've also found water less than 800 million years after the Big Bang. So going back 12.6 billion years into time, back into history, we find good old H2O.
So yeah, so water is actually quite common in space, but what makes Earth so special is that we have liquid water. It's warm enough to be in liquid state. So that is something that people don't think about, of how abundant water actually is out there. Kind of a fun question is, if the underside of your toilet lid doesn't have a glaze on it, could you use that as a streak test? There's some fun bathroom humor hiding in there as well. But check your toilet. You do want to, the streak test is typically done on a ceramic tile that's unglazed. So not all toilet lids are ceramic. And I wouldn't want you to mark up part of your home utilities there. But if you want to try it, I can't stop you. But like an unglazed tile, even if you find it at the hardware store, would work just fine if you do want to start hunting for these larger pieces of meteorites.
Please do not send your toilets in to anyone, though. Your local plumber, sure, but we, at the very least at the Bell Museum, don't need you to send in your toilet. Please don't do that. Just making sure, Sarah, because you know someone out there.
Yes. We do not have a meteorite testing facility at the Bell, so hang on to your own meteorites there. But a question came in a little while ago. Is space never ending, and how do we know? Some of these comets come from a very far distance away from us, but how do we know where the edge of space is, and is there even an edge of space? Thoughts?
Thoughts from me?
Do you have any? Yeah.
Oh, I have many thoughts on this question. I love the question. I think it's a great question because I think it makes us think about, what do we mean by space? What do we mean by the universe? And I'm going to answer it sort of on a pure, like, what does the word mean? Space is where we are. If you're right wherever you are, you're taking up space. So wherever you go, you'll be in space. So if you could travel on a spaceship as far out, as far as you could go, as fast as you go, if you could live forever and your spaceship had unlimited fuel, or if you were like, you know, a little photon, a little piece of light going across the universe, wherever you go, you'd be taking space with you. So the universe would never end that way. So that's on a pure, like, just what does the word sort of mean level. Astronomers, though, are debating this on a deeper, the deeper level of, by looking at the universe and researching what's out there. And from what I understand, you know, the general thought is that space does not end, in part because we don't think that well, in the very simple sense, the universe formed 14 billion years ago out of the Big Bang. And when it happened, it created all this, it created everything, space and time with it. And that formation of everything happened then everywhere. So the universe simply contains absolutely everything, and by that nature doesn't have an end or an edge either. Those would be my long answers to that, Sarah. I don't know if you have maybe something else, hopefully something else.
Well, if you want to come see the edge of our visible universe, we do that quite frequently in our planetarium show. So we'd love to see you and talk to you in person if you come and see us in the planetarium. We are kind of nearing the end of our time together. We have several, just a few more minutes left, but a question came in about the Andromeda Galaxy. So I'm actually going to jump back to our star map here. So the Andromeda Galaxy, they're saying it looks like an elliptical galaxy through a telescope. Well, the Andromeda Galaxy, if we go back to our star map, is going to be kind of near the center of our map here. Again, this is December around 6 o'clock at night. You can find it by looking for this kind of W of stars, or an M, based on which side of the St. Croix River you're on, of Queen Cassiopeia here. And Queen Cassiopeia is a wonderful constellation to get to know, because from there you can start star hopping across the sky. And one of the ways that you can star hop from Cassiopeia is if you find this kind of triangle here of the brighter star Shadir, this kind of triangle part of Cassiopeia actually points at the Andromeda Galaxy, M31, which is in the constellation of Andromeda here. If you imagine, here are her legs and the torso, that triangle here on the screen, and then her arms kind of extend out, some towards the middle of our map, and the other one kind of out towards the outer edge there. But M31, the Andromeda Galaxy, is a spiral galaxy, much like the Milky Way. Now, when we look at it in the sky, if you have a nice, clear, dark night, you are not going to see this really from the Twin Cities, unless you have a telescope. It'll just look like a little smudge. Like if you rubbed your finger in some pencil dust and just kind of smudged it on paper, that's what it's going to look like. And so to our unaided eye, it might look like an elliptical galaxy. But through a telescope, it is in fact a spiral galaxy with gorgeous arms kind of twirling out from that galactic center there. And the Andromeda Galaxy is our largest close neighbor. And in about 5 billion years from now, the Milky Way and the Andromeda galaxies will collide and then settle back down into one like super big galaxy, bigger than either one of them. So definitely take a look for Andromeda out. The constellation and the galaxy are visible in our skies this time of year. And one of the things coming up in that why we care about some of the meteorites and the showers we're talking about here, and if you happen to find a meteorite, they're wonderful samples, is we care about them because they kind of are little time capsules of what the solar system was like when it first formed. Rocky meteorites are going to be kind of that really early kind of debris field. And then, so the micrometeorites, the glass particles that have come in at very hot temperatures, kind of melted. Those go through a few different processes. So, the melting process, so they're not maybe as able to date them, if you will, because they've gone through some process. But they're wonderful samples of what it's like out beyond Earth and what it was like when the Earth was very primitive. In our solar system. That's one of the things we're still trying to figure out in the content of astronomy, in the field of astronomy, is how did we get here? And these meteorites and the comets, and figuring out where the comets originate, gives us clues to what was the early history of our solar system like. And so that's one of the fun things to talk about them and really think about these little rocks that travel from so far away and finally do survive that final trip through our atmosphere and make it to the ground. So I think there's a special in why I have earrings that have meteorites in them. Okay, 2 last questions are in so far, and if you do have any others, again, we love questions. Please feel free to enter them into the Q&A box as we enter our last few minutes here together. Tad, this is a question I think you've talked about before, but Ely wants to know, what about Stephan's quintet?
Yeah, let's see, off the top of my head, I want to say that's a group of galaxies. And apologize, I've been typing out some other things here. Let me just get over, if I can steal the screen share again.
For it.
Let me jump back to good old Stellarium. So yeah, if you're interested in finding things in the night sky, Stellarium is your friend, your digital friend here. I was we're looking at the Andromeda Galaxy as Sarah was talking about it there. And let's see, Stephen, so just a control F for Steve or finding. Stephen's quintet, it looks like it is an active galaxy, so I think not a galactic group, but oh no, look at that, it is a galactic group. So it looks like it is a group of 4 or 5, well, Quinn will be 5, right? Got my Latin right there, Quinn is 5, Sarah, does it sound right?
It looks like I see some five nuclei.
2, 3, 4, and then 5 down there, yeah. Yeah, so it looks like it's a small, I say small, this is going to be a massive group of galaxies then if there's 5 different galaxies there. It's pretty faint. Stellarium again here is showing about magnitude 13. Magnitude 13 is pretty bright. That's how we measure brightness in astronomy. Some of the bright stars for comparison are magnitude 5, but the magnitude scale is also logarithmic, so that's, anyway.
And backwards.
It's backwards, yeah. It is near Pegasus, though. So if you're looking for it, I think you should have good luck. And I see it's not showing up because I've actually gone and turned some things off here. There's a little too much. Let's see here. If you're looking for it, you're going to want to find the constellation of Pegasus. And I don't think we have this marked out on a star map. Oh, also known as the Deerlook group. If you find Pegasus, and the main part of Pegasus is known as the fall square, because we see it in the fall, and it's 4 stars, and you get the idea. Pegasus then has 1 wing or legs coming off from it right up here. So I would star hop down to those few stars. It looks like that's going to be Meteor and New Pegasi. Going down from those, it looks like Stephen's quintet is, oh no, it's the Deerlook group is another group there. Stephen's quintet is almost a nice triangle here that I'm seeing. So almost equidistant from those 2 stars. That would be the way then that I would star hop to start to find it. I haven't seen it personally, but that's how I would start to find it. A very cool looking group of galaxies there. I'm assuming interacting, probably colliding as we see it, as Sarah was talking about Andromeda and the Milky Way, so we can see some evidence of that going on, especially in these 2 galaxies here and there. This one could even be headed inwards to those, we can imagine. I'm gonna have to look up more about this one.
But yeah, it has those telltale, again, kind of pun not intended, but there, signs of collision. So if you look at that kind of topmost one, it has a tail kind of coming off of it. And that is a sign that galaxies have collided, that some of their stars come streaking out, creating those tails here. So these are interacting galaxies in this galaxy cluster here. There's 2 questions about the moon. I'm going to say, Joseph, maybe is your question, how old is the moon? It is, I think your question is asking. And the moon is roughly the same age as the Earth. A lot of the materials we brought back from the Apollo missions, we were able to date, and we've been able to analyze, much the way we'd like to analyze or want to analyze the meteors and the meteorites that come to the Earth. And the moon is about the same age as the Earth, and we do believe, based on some studies of it, that the moon actually originated as a chunk of the Earth at one point in time that got broken off in a collision that then reformed into the moon. So the rocks on the moon are very similar to rocks on Earth, but just slightly separate enough where we know if a rock comes from the moon or comes from Earth. But originally, before all that, we do think the moon came from Earth, so it'd be roughly the same age. And then the big gray spots on the moon there that Tata is so wonderfully showing us, those are the Maria. Those are kind of essentially dried up lava oceans. So way back during the early moon formation, the moon was much more molten and it was hit by meteors and asteroids, causing all these wonderful craters we see on the moon today. But some of those lower lying areas, the moon got filled in by some of that lunar lava that hardened and solidified into these darker Maria that we see today. Those mostly are basalt rocks. So similar again to what we have here on Earth, but just slightly different enough for us to be able to tell they came from the moon. And it looks like last question we might have time for today. And I'm going to let Tad and I answer this individually. But what do we think is the most interesting constellation to learn about? This one's going to be a hard one.
Yeah. Oh, that's a hard one.
I think I'm going to stick with Orion, because Orion is my favorite constellation, and it's a great time of year to enjoy the constellation Orion. Because it has the Orion Nebula in it, kind of hanging off the 3 stars that make Orion's belt is his sword. And in that sword is the Orion Nebula, this gorgeous star-forming cloud. But then also, if you were to look at this constellation using infrared light, which our eyes cannot see, but we have looked at it in infrared cameras, infrared telescopes, the whole constellation just lights up. So this area of the sky, there is active star formation happening. So new stars are being born in this area of the sky, and I think it's a gorgeous chunk of the sky. So that would be what I would say is kind of Orion is my favorite, and it has some great deep space objects hiding in it.
Orion is the personal favorite, definitely, but I don't know if I could choose just one. I mean, maybe I'll go with this. I'm more of a cat person, so I'm just going to go with the cat constellation of the Lynx, which we see drawn out here in front of us. It's not a bright constellation. That is, the stars that make it up aren't super bright. You need the eyes of a cat to see it, as is recorded in the literature. It does contain an object I find very cool. It's a globular cluster called Well 25, the Intergalactic Wanderer. It is one of the furthest, if not the furthest, known globular cluster from the Milky Way. It may be, in fact, a captured globular from another galaxy. And so I just think that's super cool. So I go with the Lynx, but yeah, they're all super cool. Yeah, especially, as there's been a couple questions they're asking about these deep sky objects. If you're looking at galaxies, I'd say maybe Bode's galaxy is one of my personal favorites. So Ursa Major then would be one of my favorite galaxies. Globulars like the Intergalactic Wanderer or Messier 13 would be other ones. M42, of course, for Nebula and Orion. I mean, that's like hands down, right? Mm-hmm. Planetary Nebula and Draco, Cat's Eye, another absolute favorite. Yeah, I can't choose just one.
Yeah, no, it is definitely hard to choose just one. But with that, we are at the end of our time together here. And so I do want to say thank you all for joining us tonight. These astronomy programs from the Bell Museum are made possible by Ruth and John Huss and the generosity of donors like you. Gifts of any size definitely allow us to bring these programs to you on a regular monthly basis. We hope that you enjoyed tonight's program and that you are all nice and safe and cozy inside while it snows out. And please, we'd love to see you at the Bell Museum. So come visit us, ask us these questions in person. The planetarium is a wonderful space to be when we can't get outside with our telescopes and view these night sky objects firsthand. So thank you all. Have a wonderful night. We'll see you next time.
And remember, there is a snow emergency in the Twin Cities, so make sure you move your cars. All right, have a good night, everyone.